So thank you everybody for joining us today, wherever you may be joining us from. Today we've got a webinar talking about cyber at scale on internet backbones. So for the agenda for this webinar will be quick introductions from myself and Martin, brief overview of Telesoft and who we are, and then we'll look at some of the challenges faced by sort of CSPs and internet backbone providers when they're starting to look at the scale that they're dealing with currently. Then we'll have a brief conversation about the changing of the cyber power dynamic and talking about active defense, which you may have heard us briefly allude to just now. And then we'll have a short discussion about potential commercial opportunities therein before looking at thinking about the future and sort of energy situation for platforms and the disruptors that may be affecting the market over the coming years. And then we will have time at the end for question and answers. So if anybody wants to raise any questions throughout this, please do so in the chat window. If we don't answer the question during the webinar, we'll answer it in the Q&A session at the end. Anything to add there, Martin? We're happy to move on.
Yeah, let's move on, I think.
Okay.
So, thanks everybody again. My name's Martin Rudd. I'm the CTO of Telesoft. Telesoft are an organisation with about somewhere around 14 terabits per second of cyber deployed out there, which we use to protect public and private interests of our customers. And I work closely with them to who are the large networks, as you can imagine, with that scale of data and that scale of communication. And I work very closely with them to look at the challenges which they're currently facing and look to see if we can start gaining advantage through technology, through policy, and strategically to gain an advantage for them both in the market and in ensuring they're protecting their interests.
And I'm Robert. I'm a field applications engineer at Telesoft. I've got a background in intelligence within the British military, and I've sort of got a general background and interest in cyber threat intelligence as a whole, and what the threat actors are doing and where they're potentially looking towards. And I work in a sort of fairly customer-facing role, supporting Martin with customer engagements and demonstrations and trying to understand the challenges that customers and industries are facing, as well as how we can bring those challenges into our solutions and try and resolve those.
Thanks very much. Okay, so just a quick overview of internet backbone cyber. So being on an internet backbone, visibility on an internet backbone, and it is a visibility of the internet interconnected world, and that is absolutely prime, or primo, as we've got there, which is equally as enthusiastic. So the internet backbones do give this visibility and view of the cyber battlefield or the cyber activity at a very, very high level. So nationally up to a global level, depending on what the reach is of the CSP, if they're multi-country or if they're for their nation. But it is incomplete because you're not always able to see the depth that you can in enterprise. And by that we mean you won't often get endpoint logs because you're looking at traffic moving through a network, so you're quite passive to what's going on. And also, you won't always have the keys in terms of encrypted communications. You'll have them for the assets within your own network, the services and infrastructure within your own network, but not anything else outside, which makes up the vast majority of the traffic. There are some significant challenges. Scale is really the top of the list, just in terms of the volume of traffic and the complexity of the traffic. And we're going to deal with those two particular challenges in a little bit of depth as we discuss this. The other element of being able to have this visibility of the interconnected world is be able to take actions. And we did mention it in just in the lead-in, where one of the things which we're particularly interested in is changing the current cyber power dynamic, the losing cyber power dynamic, where you have an attacker and a defender. I think an easy way to describe it is if the in any game, such as tennis, the server has the advantage, the aggressor has the advantage. Similarly with poker, backgammon, chess, all these different elements, card games, the attacker has the advantage, and we're looking to change that, and we'll talk about that a little bit as well. You're also likely to be looking at supporting your operations across multiple policy and sovereign jurisdictions, which is something else to consider. But the good news is, alongside this public and private security, which you can offer on the internet backbone, options exist for revenue generation for the CSP themselves. Okay, Rob. So when we're talking about scale, we do mean a full internet backbone, and there are some bubbles there describing some of the things which are currently on, emerging on, or will be on the internet backbone. There's a bubble there for digital society that encompasses everything from Netflix to social media, apps, and everything in between. And what we can really see is that mixed in amongst these, all of this different internet traffic, is there is cyber criminality and nation state activity, and there are big drivers in there for things like 5G and Wi-Fi 6, which are incoming, which are going to make the this complex picture ramp it up in terms of scale.
One of the key challenges that are being faced is the scale, the volume of traffic that sort of CSPs and internet backbone providers have to deal with on a daily basis. So if we sort of address each of these points in turn, and look at tech availability first of all, what is the tech availability in terabits per second?
Well, fundamentally, availability of cyber technology decreases with rate. And as you move into terabits per second, that becomes much less than at an enterprise level, where the market is relatively saturated, or at least is highly competitive and pretty mature. The thing which I would suggest, though, even though that tech availability is decreased at scale, you shouldn't compromise. You shouldn't compromise on what your goals are and what you're trying to achieve. And I think that's really what I'd say about the tech availability, that there is less tech which is available at terabits per second. It does tend to be more specialized in order for it to work at scale, but don't compromise.
Sure, and it's like another piece of a puzzle, right? Like we talk about defense in depth. If you've only got one solution looking for these threats, then there's going to be a lot of things that you're missing out on, or potentially missing out on.
Absolutely, and there are ways in which we can build infrastructure, security infrastructure, with available tech, and maximize what can be affected at or what tools we've got available to us, and what technology we've got available to us. But they work in harmony, and definitely a strength in depth and a diversity of tooling is as critical as almost anything.
Yeah, agreed. So if we've gone to number 2, then what is unique to visibility piece on internet backbones?
Well, I mean, with the scale, and this mantra of not compromising, don't sample. Don't go towards sampling of the internet traffic, because those single flows and events could be absolutely critical to attribution, or detecting a piece of malware going to a target. So don't sample, and that is difficult to maintain that visibility. So another element which is unique to the visibility on internet backbones is encryption, where, like we said previously, you won't often have the keys for the internal network. So how do you detect? And encryption is rising. The amount of encryption is rising. I'm not sure if it's about 70% of internet traffic, but it'll be around there, or a little bit more at the moment. And in order to be able to gain visibility of what's going on inside that traffic, without having the keys, means that relying on things like SSL fingerprinting, and there are a wide variety of types of SSL fingerprinting out there, from JA3 to JARM or CYU, on Google's quick protocol, internet protocol, layer 4 protocol. And all of these things give a visibility, a non-intrusive visibility of and classification of threats within traffic, or the classification of sessions, whilst maintaining privacy considerations and operational effectiveness, i.e., they're not too onerous to fingerprint.
Interesting. And from doing it a sort of passive perspective, as a node of J3 fingerprinting is, I suppose you're significantly reducing that computational power that would be required to unencrypt a single flow that you don't have the keys for, let alone sort of millions of flows operating on a network at any second.
Yes, I mean, in this universe, we live in an expanding universe, and in this universe, encryption is kind of easier to create than it is to break. There are discussions around, and there is a evolution around quantum encryption, but it isn't here and applied right now, and it certainly isn't in the same scale as being able to decrypt traffic in real time. And let's be honest, that comes with a wide amount of policy considerations, the privacy considerations. But SSL fingerprinting is a very, very good way of being able to classify things. And we can classify anything from, this is the Emotep botnet or Loki bot malware, to command and control, to, this is an FTP file transfer from Dropbox. And we can determine from that, this shouldn't be happening, and therefore it's data exfiltration or data theft from this organization over here. So there's, there are indications and insights using SSL fingerprinting that we can get. So again, to the visibility piece, looking at it in a wider context, we won't have the endpoint logs as well, like in enterprise, again, unless it's your own internal infrastructure. So you're working with less pieces of the puzzle, but more a bigger puzzle. And that's well worth noting that, in a robust and comprehensive security posture for an enterprise, you'd be looking at absolutely everything you've got available: endpoint logs, you'd be looking at your internal services, all of these different things, and putting them all together in context of the network traffic and the network behavior and behavioral analytics, all these different things. But you don't have all of these things available on an internet backbone, so you have to be careful about what you're doing. And that naturally leads into the accuracy of what it is that you are able to collect. So highly accurate metadata records like IPFix are, highly accurate metadata records, and using technologies like IPFix and using standards like IPFix are really good foundational blocks for that analysis and investigation. And you can support them with content analysis, like targeted PCAP capture and things like that, to reverse engineer binaries or for a deeper investigation. And by using really accurate metadata records, standardized metadata records like IPFix, it reduces like the platform size, the storage requirements, and the cost, and the power, and the footprint of the platform. So you get cost benefits associated with that, as well as performance benefits. But you still need to be able to pivot between your metadata records, your PCAP or targeted content, and targeted capture content, indicators of compromise, behavioral analytics or behavioral anomalies, cyber threat intelligence. You need to be able to pivot across all of these seamlessly. I guess the last thing on the visibility piece is a kind of slightly crazy one, which is that the actual digital estate that you're monitoring is, the digital estate that you're trying to protect is constantly moving. So being able to dynamically map the digital estate, simply put, most large organizations don't know what their digital estate is. And so you have to take a position where or one of the positions which you can take is to continually discover your digital estate using BGP analysis, border gateway protocol routing analysis, and mapping the network continually. And you can also provision your digital estate of known assets, whether they be IP addresses, hosts, or even horizontally, like VLANing and things like that. And within the context of a moving digital estate that you're working with, building in an active defense capability for your own infrastructure, for your own assets, your own digital assets you potentially are prioritizing, is absolutely critical. So I think, and we'll come on to active defense again shortly.
Yeah, we will. But you mentioned like highly accurate metadata there, and that sort of ties in with our last point of data quality. So how does the data quality impact security operations in their day-to-day?
Well, a lot. I mean, a huge amount. So it boils down to, really simplistically, that better decisions can be and actions can be taken with highly accurate data. That then leads into more comprehensive digital investigations that can be undertaken. If the grassroots of your data are accurate, then the downstream tech, the downstream teams, and the downstream processes can perform better. And by that I mean, things like machine analytics, kind of anomaly detection, that side of things, but also by accuracy and removing the pressure downstream. If you do things like at the point of capture, you pre-join the data. A good example would be on most internet sessions. You get a kind of the movement from the client to the server, an upstream or an uplink network session, and you get a downlink network session. They might be coming through two different parts of the internet fabric, the CSP's fabric, but joining those two discrete uplink and downlink flows together and serving them as a single accurate record really dramatically reduces the amount of downstream processing and compute and storage. I mean, it reduces the amount of downstream storage by it reduces down to about 60% if you're holding them separately, which is huge. So that's,
you're reducing the sort of investigating that the SecOps teams have to do, right? As opposed to looking for each of those pieces of information if they're already being stitched together and it's already there. So that first piece of investigation has already been done for them.
Yeah, absolutely, and that works for all sorts of different things as well. Sort of enriching the records as well, so that kind of you don't have to try and stitch together, kind of the organization that owns that IP address or where it's come from geographically, or kind of which part of the network it's traveled through. All these different things. If you can do those at the point of collect, then it's very, very accurate and removes that or reduces significantly the downstream processing compute, but it makes those downstream teams' lives much easier. Okay, I think that's probably about it. I don't think I've got anything else to say about the data.
Yeah, I was going to say, I think we covered volume quite comprehensively there.
Yeah.
Thank you. Let's move on and talk about the challenge of complexity. So I suppose you've lost the information on the side there, but there's supposed to be a title on the left-hand side that says entity sets with a caption of case study. This is something that we've utilized in the past with some of our customers to try and simplify this element of complexity for them. So if we start talking about entity sets, then how can we make sense of massive traffic on a sort of communication service provider or an internet backbone?
Yeah. So the first thing to do is to start grouping things. We call these groups of things entity sets, and as you can see on the screen there are some examples of entity sets which kind of mirror what we showed previously with the technologies and things when we were having a quick look at the overview. So this is a kind of a good illustration of why it's efficient on a range of levels, and a range of operational, tactical, and strategic levels, to group elements into single objects, because then you're basically protecting single items. It's a lot easier to protect against a specific hospital coming under attack from a network or ransomware campaign than it is to try and defend all of those individual IP addresses. And when you start building that up onto the internet, you've just got millions and millions of IP addresses. So being able to group them at a high level, both the attacker and the defender, is really, really useful. And it significantly clears out the picture, massively clears out the picture. And in this particular instance, in this use case which we've got with the entity sets on the screen, the fact that there was a targeted attack from an APT group against a vaccine research institute was, and being able to determine that and classify that made it a much more effective strategic response to that attack than the networker malware, the networker ransomware service running a campaign against hospitals, where you could actually start responding to that at a campaign level, and taking addressable action, kind of providing threat intelligence, or providing to the hospitals themselves, kind of taking the steps on the firewalls to block that traffic, all that sort of thing. And being able to once you've seen it once, you can place that security protection, that mitigation across all of your estate, and therefore all of your customers, and look to take an advantage away from the advantage of surprise away from the attacker, in this case networker. But it's quite tricky to classify things, so you need to figure out what it is that you're trying to protect. So there's things that you can provision up, and kind of your own infrastructure, that sort of thing. We can also attribute IP addresses to their owner, to the organisation that owns them. And we can do that automatically, and we can discover other entity sets using things like BGP, or using analytics, and then automatically have those put back on. So you have a sort of combination of what you describe as provisioned, semi-provisioned, or sort of supervised, semi-supervised, and unsupervised entity sets, but they all boil down to the same thing, which is to give the defenders single things to defend, and single things that are attacking them, which makes the picture an awful lot clearer. But you do want to still maintain that ability to go from that high level immediately down into the low level, to do forensics, kind of on the metadata, to do forensics on the PCAPs and the binaries, to do forensics on very, very low level.
Yeah, absolutely. So it kind of ties back in nicely to the previous point of the visibility, and it's having that complete visibility from that really sort of high level strategic overview perspective, right down into the detailed low level technical information where you're conducting the investigations.
Absolutely, very much so.
So what else can we do with entity sets then?
Well, essentially, you could create these, essentially entity sets are created, and are used to classify things like your own infrastructure, your own services, or even your own customers. So you could group together your customer assets, even if they're geographically spread. A multinational company might have offices, kind of elements of data center, all these different things. And be able to group those as a single entity, regardless of where they're geographically located or logically located. If they're all grouped together, you can protect that customer, or you can protect that service, which makes life makes life an awful lot easier, especially in hybrid and distributed, the hybrid and distributed work that we systems that we currently see, and that are being used. The other thing which you can do with entity sets is, I think what you did mention it, that you can see these attacks, you can see atomic attacks at a strategic level. So that it's the example on the screen is ideal for this, where you can actually see this, and be able to respond more effectively, and you can respond at strategic level. So you can eventually fight strategy with strategy, operations with operations, and tactical with tactical. And having these entity sets enables the strategic decision makers to be able to see things at a high level in the context of history very, very quickly, and then affect that strategy in real time on the front line, which is again absolutely critical for changing the cyber power dynamic from the traditional attacker defender. It also enables a massively reduced alert and investigation fatigue. It makes the SecOps task easier to triage incidents because kind of they've got preferential customers, or or they want to extract out that internet traffic which is only pertinent to those customers, or they want to be protecting their own assets, their own infrastructure and services. And I think this is these entity sets kind of replicate essentially the internet from the ground up. So they build these blocks of photons, going through pipes and network infrastructure, and you can get that picture, and you can move up to a protocol level, up to an application level, up for a threat level, and then up to kind of an organizational level, or even on the next step, as smart cities come online and digital twinning comes online, these kind of technologies and these kind of societal changes, technical societal changes, we'll be able to start having entity sets which are just smart cities, and then being able to burrow down into the traffic control systems or the power and utilities, that sort of thing.
Very interesting. I think from here we'll move on to what has been mentioned a couple of times now is active defense. Do you want to discuss that in a little bit more detail?
I will do. I mean, I think one of the things about the attacker defender dynamic is that it just fundamentally needs to change. An active defense is a way to address that initial advantage that the attacker has by I think the quote there is quite good. It's by employing a limited offensive action and counteracts to deny a contested position to the enemy. So having this backbone internet visibility is really, really powerful for being able to do this. And essentially, one of the things you can do is you can see what the attacker is trying to do. And if you route their traffic and route their attack into an area of a controlled area, and then start taking them on, or kind of laying tripwires and deception technology in front of them as they try and maintain their attack. What you can start doing is you can start building up a picture of the capability of the attacker. A really good example of this is that say an email comes out with a new strain of ransomware. Instead of blocking the email going somewhere, what you do is you forward the email over to a safe detonation environment. You let the email detonate as if it had been triggered by a user, and then you see what the command and control infrastructure is behind that, and it exposes the command and control infrastructure if you're monitoring it carefully enough and then you take that information, that intelligence about the command and control infrastructure, and then you place that back on your main security infrastructure. You can then start laying out this protective mesh throughout your estate and your control and all the and the communications which are going through your estate. You can start laying the protection down in that particular way, and in which case nobody's lost here. But what you've done is you've taken away some significant advantage that the attacker has got by already putting in place the defense before they've actually mounted a successful attack. Another element of this is if you've got a contested area, to enable the attacker to attack a target, and if it's a synthesized target or a synthesized target, or it's a deception environment, then you can you can capture their traffic, start reverse engineering their binaries, start reverse engineering their TCPs, and again start building up a response, a mitigation plan, a response plan, which is based on more knowledge. You can also start laying a few tripwires and roadblocks in the way, and essentially challenge set the attacker tasks to see what their capability is and see how evolved they are, and start again, seeing where they start failing, because that can also, if they're unable to succeed in the task, that could be the indication on how to mitigate their impact, or at least degrade their campaign to a point where it can no longer degrade their foot. Mitre Shield have come out. So the guys who did Mitre Attack, Mitre Shield is their new thing which came out in August, which describes active defence. And I'd certainly be going to have a look at that.
Awesome. So from an opportunity perspective, then looking at it from a talking about changing the cyber power dynamic, looking at the opportunities that lie within CSPs and internet backbone providers, how do you where do you see the potential opportunities lie?
Well, I think there's a clear opportunity, which is revenue generation for a carrier clean pipe service. Essentially, kind of some of the carriers are starting to either roll this out or look at it, but there's an ability there to provide what's effectively clean internet communications to customers, and that's a revenue generation service. And I think that's a big thing. It also is with the CSPs being the bottleneck or a lot of the bottleneck for cyber and threat activity, they're in a unique position to be able to affect this as well. Another thing is that the cyber data has an enormous amount of equity that can be used wider across the organization. Kind of lots and lots of organizations at the moment are trying to break down the silos of data because they're these huge platforms which are being used for business intelligence, fraud, compliance, kind of cyber. But the cyber one generally is one of the bigger ones, and definitely one of the ones which has the accuracy and the technology backing behind it, which can be and that data equity can be released to the better and commercial imperative of the business. Having strong cyber posture, being a good carrier of traffic, also enables that strengthening of the international relationships as communications companies join together and pass data between one another, and that then naturally leads into market expansion opportunities. And it's not just the security, but you end up getting sort of technical intelligence collaboration, which are these kind of long-term relationships which are built, and these again promote strength and growth in the longer term for organizations. And the last bit in there, I think the last point which we've got there is the other opportunity is that the CSPs, the backbone internet CSPs, are one of the front lines of cyber warfare as well as cybersecurity, or kind of commercial, for want of a better phrase, commercial cybersecurity. And the onus is increasingly on the private sector to provide sovereign security, and that's both in terms of communications companies, vendors, all these different pieces of the puzzle for the cyber puzzle. But there is a kind of sovereign and nation state driver for this technology. One of the things which is a big thing, sort of, which organizations and society is facing, is the increasing use of energy for compute. And Moore's law, which whether you can Moore's law describes that I think it's the compute power doubles every 18 months.
Number of transistors doubling every 2 years, I think.
2 years. Okay. So what you've got is so the compute power, which you can argue is coming up to kind of reaching the end of Moore's law's prediction, and Kumi's law, which is energy and the energy and the compute are intrinsically linked, mean that these platforms are getting hugely expensive to install and run. So looking when you're dealing with platforms at the scale of internet backbone cyber, it's good to be looking around at other technologies, like things like FPGAs, which are these massively high performance but very low power parallelized compute, really high, really strong on the compute power, and also kind of low power high performance storage like NVMe, and all these things. They lead to better operational performance fundamentally, but really it's about that they lower the costs and they improve the return on investment as well for the operator.
We've also got a slide on disruptors if you wanted to cover that, Martin.
Oh, I think, well, there are disruptors, but I think essentially there's so much data, we're getting quite close to the end of our time, I think, but one of the big things is the amount of data and kind of the ICT technologies, the information communication technologies like 5G, IoT, Industry 4.0, all these things, they are massive drivers for just a volume of data growth, which is going to put pressure along with edge compute. What's about to happen is that the core of the network is going to come under pressure because of edge compute. This pushing higher value services, higher volume compute. Kind of gaming, business operations, business services. Kind of high bandwidth gaming. All of these different things getting pushed out. Machine learning, augmented reality. All these different things which are incredibly high compute and are driven by data compute and bandwidth. All of these things are getting pushed out to the core, which means pushed out to the edge. Sorry, which means that the core is about to come under pressure, and so any technology or any platform has to be able to handle any core network platform is going to have to be able to handle that, and that's going to be a seismic shift in the amount of data which is moving. Another thing which is a big driver is legislation and policy. And we've seen a lot of legislation and policy coming out across the world. And initially, it was around sort of like GDPR, or one of the things was around sort of GDPR and the individual. But then it started coming around tech, kind of IoT, designed by security by design, IoT, and then things like the India Protection Act, in the India Data Protection Act, started looking at data as a sovereign entity. And an organisation which is operating across multiple policy and sovereign jurisdictions is going to have to adhere to these. And these are, again, big drivers for how the platform performs.
We've got a 400 gig flow probe. That's our sort of network monitoring solution. 200 gig CERN, so our high rate intrusion detection capability. And then we've got our analytics and forensics and data retention platform, which is a TDAC. And these all combine and work with one another to really provide that visibility over the CSPs and internet backbones, and allow the provisioning of digital assets within these sort of high rate networks, and then enable that really strategic high level overview of what's going on within that digital environment, right down to the lower level, the investigations, the digital forensics investigations that are required to really understand what's been happening within your network, and why.
That's great. And I think we can offer a demo of our kit running if you get in contact with us. Well, there'll be a follow-up email with a pack on the webinar. And if you get in contact with us following the webinar, we can give you a demonstration of how our kit works in this context. But I see we've got a couple of questions starting to come through. So one of the questions is how does cyber risk programs and capabilities align to industry standards and peer organizations? That's a really interesting question. So I'm going to take it a couple of different levels. So at one level, it's you could make a good case for these cyber risk programs are implemented in organizations, but they are at an organizational level, and the impact on the internet backbone is that you can see if those cyber risk programs are actually having any effect on the organizations, or on market sectors, or on nations, or at a wider level, and be able to adjust the cyber risk programs and the capabilities to meet and to sort of effectively put holes in the policy, or to adjust, provide intelligence to and measurement of how effective those policies are actually on the overall security posture of either the organization, the nation, or even a sector of the market. And what I would say in the other context of that is once you start getting into um, the standards and the industry, certainly the industry standards, are the same type of rules apply on the internet backbone. So a good example would be the MITRE framework, both MITRE ATT&CK for TTPs and for the MITRE SHIELD for the active defense. And both of those things can be applied at an organizational and at an internet backbone level, and they can both work in harmony. And that's where we will really see a big uptick in being able to change this cyber power dynamic, where you have both the communications providers, and the organizations working together with a shared and agreed standards, and being able to implement their own capabilities through with vendor diversification and that sort of thing. But then also be able to measure what the impact of those changes are, and those frameworks are, and have it as a kind of improving cycle. And those things working in harmony will help change the cyber dynamic again. I hope that answers that question. Uh, there's another question, which is, if my organization has offices in different countries, what would be the most effective way to provision them as entity sets? Well, we can, like we mentioned earlier, we can provision them up as hosts, or we can provision them up or they can be provisioned up as hosts. They can be provisioned up as horizontal elements within the network, sort of VLANs, that sort of thing. IP addresses, we can actually automatically classify it as if any IP address that your organization owns, we will bring that in as well. So we can actually do it at an organizational level and turn all those things into entity sets. What I would say is that the network these days is as a kind of this mesh of the kind of core, which is always going to be high speed, or which is often a high speed fiber, but you're also going to have elements of cloud or virtual infrastructure. And we have other technology which works in harmony as a mesh defense alongside the three products which are on screen. And those software versions of these can be deployed in cloud environments, and they form a complete visibility mesh across the different areas of the organization. And individually, they also become entity sets in their own right. So you can protect an individual office. You can start seeing if an attack is against against your video delivery infrastructure, maybe, or against your business infrastructure. And all of these, the software and the hardware platforms work in tandem to provide that complete mesh, and you start having a mesh defense against a mesh attack. So from Henry, there's a question. Would it be possible to see a demonstration of the NDR platform, as well as more information on the products themselves? Yes, absolutely. And we'll be sending out some details on that following this webinar. And we hope that you get in contact. You've had some value out of this webinar, and that you will get in contact with us following with the pack, and be able to see a demonstration if you'd like it. There's Fadzai has said, are all three of your systems mentioned? Are all three of your systems mentioned as the NDR platform required for visibility over your network? Yes, I mean they form a kind of a base framework on which to build that visibility piece. Simply, Fadzai, if you can't see it, how are you going to do anything about it? If you can't see the threats, how are you going to do anything about it? And that is ever more tricky the higher the rate goes. Being able to see everything, having that visibility at internet backbone scale at terabits per second becomes very much more challenging. And these three platforms work in our three products work in harmony to be able to provide that. And I think that's probably quite a good place to bring it to an end. That it's about the scale, and it's about being able to see, being able to handle the scale, and being able to handle the complexity of the traffic on internet backbones in an ever interconnecting world. And we hope that you get in contact and look for a demo. If not, and you'd like to hear more about active defense and the routing attack on the APT infrastructure, again, speak to us. And hopefully we'll speak to you in due course, and we'll look forward to seeing you on the next webinar. Rob, would you like to add anything?
No, I was just going to say thank you for everyone that joined from wherever you may be joining us from. I appreciate some people potentially being a less less friendly hour of the day, shall we say. So thank you very much. Yeah, I think that's
Brilliant.
about it.
Great stuff. Well, we'll look forward to seeing everybody next time. And and we'll be sending out a pack with information following this webinar to you, with a link and a few other bits, and some and potentially some goodies as well, which you might be able to provide to your security operations team. Have some further reading, and I hope everybody has a good festive season, and we'll see you in the new year. Bye bye.
Thanks, Martin. Thanks for joining us.